All right, so instead of just posting, I'm going to post the PDFs of these, but I'm also going to do this here with you guys. So I'm going to work in the order uh, in which I had the handouts in the front of the room here. So if you need to follow along here, you go for it. Okay, so Judy always waits until her gas tank is nearly empty before refueling. She keeps track of the distances with each tank. Okay, the distance varies depending on the weather and the amount of she drives on the highway. The distance has a mean of 824, okay, 824 and 28 kilometers. Okay, standard deviation of 28 kilometers. Sketch a normal curve to show distribution. Mark the kilometers driven for values 1, 2, and 3 standard deviations from the mean. Mark the corresponding percentages. So we're going to quickly go ahead and do that. I'm going to make this my center here. Let's do this. It's my center. And I'm going to go 1, 2, 3 to the left, and 1, 2, and 3 to the right. Okay, so I line it up, make my line. The highest is here. Just gonna do this. Keeps going. This is distance in kilometers. Label that, and we'll section off this curve with the corresponding standard deviations. There you go. I'm going to put down the number here. This is 824. And I already did this ahead of time. So 852, 880. Just keep adding the standard deviation to it. Subtract from 824 to get 796, 768, and 740. And I know it doesn't ask for it, but we'll put the z-scores underneath it. Okay, so we know that this would be 0, 1, 2, 3, -1, -2, -3. There we go. Put the percentages in there. Right, so we start with 0.15%, 2.35, and so on and so forth. There you go. That's our curve. So use the graph to answer the following. What percent of time, or what's the probability, same thing, does she drive between 796 and 852? So 796 is right there, 852 is right there. That would just be 34 plus 34, right? 68%. What percent of the time does she drive between 740 and 796 kilometers? So 740 is right here, 796 is right there. So in this case, it's easier to just add it up. And so you get 15.85% of the time. Okay. Between what two values will she drive 95% of the time? That should tell you something. 95% of the time is would be going 2 standard deviations to the left of the mean and going 2 standard deviations to the right of the mean. So we're actually asking for these two values in this case because we're given the percentage, right? That would be between 768 kilometers. Sorry, what happened there? And, right, 880 kilometers. There you go. Then bonus, what percent will be lower than 800 kilometers? This used to be an AC, so at this point we would have just started inverse norm and normal CDF. You should know this. So what percent will be lower than 800 kilometers? We will just go normal CDF and then go negative 10,000, 800, and then this is 824 and 28, and we'll multiply that by 100, right? So that gives us 19.57% rounded. 19.57% of the time she gets she drives less than 800 kilometers on a tank. Okay. Next, a manufacturing company produces 1 kilogram bags of sugar. Okay, the majority, that actually means something to us. The majority, I don't know if you remember, but that would be 99.7% of the time, right? The majority of bags range between 950 and 1070. Assuming the mass of sugar is normally distributed, which has to be the case if you want to work with these questions, calculate the mean and the standard deviation, draw the bell curve that accompanies this data. I will show you how I do this. This is basically by hand, right? This is mean and standard deviation by hand, because you have nothing else to go by. Okay, so I will draw a curve real quick here. And one thing we know for sure, right? I will make a smaller one. If this is my mean, I'm going to go 1, 2, 3 to the left, 1, 2, 3 to the right, and I'm going to draw my line. You should know, right, if this is my average here, if it talks about 99.7, it's basically telling me that the lower value, which is 950, right, goes right here, and the upper value, the 1070, goes right here. I want to mention a few things. Both of these values are the same distance away from the average in this case. That won't always be the case, but if they give you either a 68, a 95, or a 99.7, then that is the case. You're the same distance away from the middle. Okay, but it could be that they give you a z-score for this one and a z-score for that one, and it might be that you're like this, for example. One value is right somewhere in here and the other one is here. So just use the formulas that I gave you. I will find my standard deviation first. Standard deviation calls for upper minus lower divided by the z-score of the upper minus the z-score of the lower. Okay, that is the formula I gave you in class. So we know that this has a z-score of -2, this has a z-score of 2, right? If it had said, 95%, or sorry, I'm actually getting this wrong, right? I'm pretty sure you caught it. -3 and 3, sorry, because it's 99.7. If it had mentioned 95% of values are between these two, then it would have been, right, 950 would have gone here, and the z-score would have been -2. Okay, so this is the z of the low, and this is the z up, right? This is the upper and lower, upper, lower, okay? So to find the standard deviation, we go upper minus whatever the lower is, 950. So if that had been a negative, you would have ended up with double negative. Then you go z up minus z down, or the lower one, right? Like this, double negatives. So that ends up being 120. This is 120 divided by, this is actually plus, right? So 3 plus 3, that's 6. And so you end up with 20 kilometers. That is in this case, right? That represents kilometers. So that is my, sorry, you couldn't see that. That is my standard deviation. So you figured it out. To find the mean, you can choose either one of these to start. Let's say you want to go with that one. So to find the mean, if you want to use that one, it's actually value minus standard deviation times Z, or Z times standard deviation. I can't remember exactly how I gave you that. So if you're picking this value here, 1070, minus, there's a 3 as your sorry, no, standard deviation is 20, sorry, but the z-score is 3. If you had picked this value, 950, you put 950 in for value, minus standard deviation, which is 20, but this z here would have actually been negative. And then that negative and this negative turn positive, because regardless of which one you choose, you should end up with the average in the middle. So this is 1070 minus 60, right? 1070, so that's 950. No, wait. I'm getting this wrong. Because this would be 1010, right? Yes, sorry, I'm off here. 1010 kilometers is. Oh, I'm actually completely mixing it up with the other question. My goodness, this is grams. Because we're talking grams, right? And this is grams as well. I don't know why I was talking kilometers. That was the previous question. Okay, so grams and grams. So you found your mean and you found your standard deviation. I would always say find your standard deviation first and then find your mean second. Okay, I did not draw the curve, but that's all right. In this particular case, I'd be a question like that. That's what I would really look for. But sure, you can make your bell curve for sure. And this is now 1010 grams. So you should be able to go up 20 at a time and land at 1070, or go down by 20 and land at 950, right? So this would be 990, 970, 950. There we go. It works out, right? So if you had to fill in this graph, you do the same thing as before, and you just put in the percentages. 2.35, 13.5, 34, 34, 13.5. It helps me to actually say it out loud, because right, that way I have it, right? So we know that from here all the way to here, right, that would have been 99.7% of values, which ends up telling us that we're going 3 standard deviations out, right? That's where the 6 comes from. That's actually the number of gaps, number of standard deviations in between them. Okay, hopefully that helped. And then we go to the back of this. Okay, and here we have that. The data represents the number of points scored by a high school basketball team. It's asking, does it seem to be, or does it appear to be normally distributed, right? So we're going to figure that out here. Let's figure out the mean and the standard deviation. So the mean and the standard deviation. I'll pause this. You go ahead and enter it and figure that out. So here it is. I figured it out. And I'm just going to write it down. So this would be 67.81 points on average, and 7.62 points on average. Okay. And calculate the frequency tally using your standard deviation as the interval width. If this confuses you, I called it frequency line, right? Using the standard deviation as our interval width. So let's go ahead and do that. So we make bins, right? This is my middle here. I'm going to go 1, 2, 3. I'm just going to leave it at that. 1, 2, 3 that way. Maybe I'll make this my middle. So I will go 4 that way. And then I go 1, 2, 3. I'll make my line first. 4. Right here, keep going a bit. So this would be my 6781. If you add standard deviation and you subtract, I will just copy these values down. You get 37.33, and you get 44.95. You get 52.57, and then you get 60.19. Keep adding, right? To the right here, this would be 75.43. Actually, is this right? I'm just gonna check here if because I did it slightly differently on the original. So let me just check here. I'll pause. Yeah, we're doing good here. 75.43. This is 83.05. And this is 90.67. And I just have to add one more, 90.67 plus 7.62, just for good measure, just to make sure we have bins for all the values, right? So this would be points scored by the team, right, along the x-axis here. Let me just zoom out a bit. And then let's just make our bins real quick. You sort your list already. Okay, and then we place them in here. So I sorted mine already. So I'm going through it. 58 would be right there. Can't see that, right? But 58 is right there. So you just go through the list, right? 58, it goes in here. 59 still goes in here. 59. 61 is already in here. 61. 64. 65. 66 is still in there. 66. 67 is still in there. 73 we jump. 74. Another 74. 75. 78. 85 goes in here. And that's it. Right? So just quickly checking 2, 4, 6, 8, 10, 12, 14, 16. Just making a note that I have 16 values that I'm considering. And let's see if this adds up. 7, 4, 1, and 1. 10, 14, 15, 16. So we're good. Okay. N is equal to 16. Make note of that again. If I add up all the values, create a histogram to display the results of your frequency chart. I will actually do this here. I'll take a moment to do that. So it's actually almost done already for you. And it's good to review histograms. So watch what I'm going to do here. I'm going to replicate this along the x-axis, but I won't spread it out as much. So I'm going to make markings every centimeter. So I need in total 8, right? It's kind of not necessarily. We could start here at 52. But let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to go 9 marks, right? So this is points scored. This would be number of games, right? Frequency, games, right? How many games, and how many games did that happen, right? So basically you just copy down these values. 52, 57, 60, 19. It's going to get a little crowded. 67, 81, 75, 43, 305, 90, 67, and 98, 29, which is, it's somewhat irrelevant to have the empty bins in there. But notice that I'm going up consistently, but the first is not 7.62 jump, right? This chunk. So we introduce the zipper. And the highest value in frequency terms of frequency is 7. So I'm just going to go up to 10 maybe. Right? I'm going to go half a centimeter at a time. See if that works out. 1, 2, 3, 4, 5, 6, 7. Perfect. So I'm just going to leave it like that. I'm just going to mark 1, 2, 3, 4, 5. Right? I'm going to have my 5 kind of standing out like that, and that's accurate. Histogram is the bars. So 52 to 60, right? This one here has a bar of 3. So we actually go all the way up to 3. And then 7 all the way up to here. So I'm just going to make a mark there. 7, and then it's 4, and then it's 1, 1. There we go, and then there's nothing elsewhere. If you wanted to do a frequency polygon, you just take the midpoints and just connect them. Just make sure you connect them to 0, right? This is connected, and then you go down like this. Okay. There it is. Points scored, everything. That's your histogram. So basically just transfer these x values. So we're using our standard deviation as our width, as our x scale in a sense, right? The side of this data is normally distributed, explained based on general characteristics expected and normally distributed data. Be specific. So we're going to go plus or minus 1 standard deviation. We're going to check. And maybe it's a good idea to just clearly label your mean up here, right? So 7 and 4, 7 plus 4 divided by total of 16, right? So that's 11 over 16, which turns out to be 68.75%. That's very close. Okay, that passes, plus or minus 2 standard deviations. You go up here and notice that it's basically, if you go 2 back and 2 front, it's everything except for 1. So that's 15, right? 15 over 16, which turns out to be 93.75% versus 95. Passes beautifully. And the last one will be 16 over 16, which is very close to what we want. So this passes, right? So we would say, we would conclude here, data is normally distributed, since it follows the 68, 95, 99.7 rule. Okay. You can also make a case that it is somewhat symmetrical. Okay. You don't have like a big peak and then it goes down back up, right? So that's kind of what you want. You want kind of like that peak and then it slows back down. So that's that, right? That's for now.